Welcome to the field measurement study on intersection control delay. Today we'll be using the Q-count technique as outlined in Section 6 of Chapter 31 of the Highway Capacity Manual to measure how long vehicles are delayed at this busy signalized intersection. Each team of two will be assigned to one stem of the intersection, where they will track the vehicle queues and arrivals. For this survey, we'll use three primary tools, as described in Section 6, a digital countdown timer, a volume count board, and a laptop for real-time data collection and delay calculations. These tools will help us accurately count vehicles, track time intervals, and calculate the delay for each vehicle. Each team will consist of two observers. Observer 1 tracks when vehicles join the queue and records this data at the start of each count interval. Observer 2 records the number of vehicles arriving in the signal cycle count, helping compute the fraction of vehicles stopping. Observer 1 records the number of vehicles in the queue during each count interval, making sure to include vehicles that stop during the green phase. This data helps us estimate the time in queue per vehicle, which is key to calculating the overall control delay. Observer 2 counts all vehicles arriving during the survey period, noting whether they stop at the signal and when they do so. The count of vehicles that stop during each signal cycle helps us calculate the fraction of vehicles stopping, which is crucial for determining control delay. As vehicles continue to arrive in queue, observers are busy recording data and ensuring accurate counts for the delay calculations. After collecting the data, we calculate the time in queue per vehicle by using the formula from equation 31-184 of the HCM. The formula to calculate the time in queue per vehicle is time in queue equals 0.9 times the sum of vehicle in queue counts divided by the total number of vehicles arriving. In this formula, the time in queue is represented by DQ, and the sum of vehicle in queue counts is represented by VIQ. While the total number of vehicles arriving is V total, we then apply a correction factor to account for deceleration and acceleration delays, as referenced in Exhibit 31-44 of the HCM. The correction factor adjusts the delay calculation based on the approach speed and the number of vehicles stopping per lane. Finally, we add the time in queue and the acceleration-deceleration delay to compute the total control delay for the lane group. To calculate the total control delay, we take the time in the queue and add it to the adjustment for deceleration and acceleration delay. We've now completed the data collection and delay calculations for this intersection, providing a reliable estimate of the control delay. This data will now be used to evaluate the level of service loss for the intersection. Thank you for joining us.